Hi folks, welcome back to Physics with Captain Rod. I'm making this video here to help you understand a little bit about what's called magnetic induction and Faraday's law of induction. So what we're looking at here, and hopefully you can see my cursor on the screen here. Here we have this coil here next to this magnet, and you'll notice that there's a certain number of field lines going through that coil. Now hopefully you've watched my video or other videos on magnetic flux. You have a magnetic flux anytime you have a number of field lines that are going through an area here. And this coil is ultimately hooked to this bulb, which will go on and off when there's, in theory, any sort of electrical current, and we have this voltage measurement. Notice here that the magnet, when it's not moving, we don't get any voltage in this circuit, and there's no bulb. The bulb isn't on. Now, if I take the magnet and I move it maybe away from the coil, you notice that that bulb went on a little bit. If I move it towards the coil and then away, towards, away, and so forth. Now, what's important to realize, what this simulation is demonstrating, hopefully for you, is that anytime you are changing the magnetic flux through this coil, we are inducing a voltage in the circuit. Now, I can do that. I can change the magnetic flux either by removing the magnet or by flipping its direction, because right now the field lines are going through this coil from right to left. If I reverse the magnet direction, now they're going through from left to right. So what I'm going to do is simulate rotating the magnet here. And you'll notice that as I do so, the voltage is kind of bouncing back and forth, right, left. Now, what that means is that the voltage is in one direction for one case, and then it's in another direction for another case, meaning that the current's actually reverse direction. Now, take a look at what happens if I move the magnet over to here with this coil that's only got a couple of loops in it, and I repeat the experiment here. I rotate the magnet, and you notice that the light bulb goes on, and you notice the voltage kicking back and forth, but the magnitude is not as large as it was down here. Again, notice, watch how far the needle moves. So, what I want you folks to get out of this video is changing magnetic flux through any sort of loop like this will induce a voltage. And the more wires there are here, if you will, the larger the voltage that's induced. And although I'm not going to write it right down right now, how fast you change the flux is a factor with how much voltage you induce in a loop. Now, this is meant to be just a conceptual video, so I'm not going to get into mathematics of this, but pay attention right now. There's a significant magnetic flux, because you'll notice there's like 1, 2, 3, 4, 5, 6 field lines going through this area, but look over here, no voltage. It's not until you change the magnetic flux by either decreasing it or increasing it that the needle moves. So again, what is this meant to do is to demonstrate that you can induce voltage by changes in magnetic flux, and also the magnitude of those voltages will depend on how many loops you have through the coil that you're changing the flux for. So just meant to be an introductory video. I hope that this has helped at least get you started thinking about Faraday's law of induction. I'll be making more. Have a great day.